Yeah, we have now Alex Liu. He's the vice president from Cyberon, and he will be the topic DSpotter, phenomenon-based local voice recognition solution. So let's listen to it.
Hello everyone, this is Alex Liu, Vice President of Cyberon Embedded Solution Business Unit. I'm happy to be here to give you a brief of our algorithm called Cyberon DSpotter. It's for voice trigger and local command recognition on resource-constrained edge devices. It could work in always-on mode to detect the wake-up word, and also works for multiple command recognition to achieve local command and control functions. DSpotter adopts CNN-based acoustic model to provide high recognition performance, especially with high noise robustness. The model and algorithm are downsized for low-resource platforms, but also well optimized to keep the high recognition performance. Unlike most NN-based wake-up word solutions, DSpotter uses phoneme-based approach for keyword modeling. Phonemes are the basic elements of a language. All phoneme models of our supported languages are well pre-trained by Cyberon, and we provide a tool for developers to create their customized keywords easily, just by text input. The tool will predict the pronunciation and generate the corresponding recognition model automatically. There is no need to collect a huge number of training data for specific keywords. So it heavily reduces the cost and efforts of developing voice recognition products and help developers to meet the time to market. Now there are more than 40 languages supported by DSpotter, covering most major languages over the world, and including some localized versions for regional accents. DSpotter uses quite low resources, and we provide a couple of sizes of the base model for developers to select according to the available resources of their products. You can see one feature of DSpotter from the spec. Only very few additional resources are required for a keyword. For example, on most Cortex-M4 MCU, DSpotter is able to support around 100 commands. It increases the flexibility of user commands. DSpotter has been ported onto a lot of MCU and DSP platforms for edge devices, and widely applied on many fields already, including automotive, wearable, smart toy, media player, home appliance, IoT devices, and so on. We know that edge computing market of voice recognition is growing rapidly. DSpotter is the solution we propose to solve the problem of recognition performance and developing cost. Welcome to contact us if you are interested in this solution. Thank you for your attention. Goodbye.
Thank you, Alex. Very interesting. I had a question. So you develop an algorithm. Can you describe like what kind of algorithm do you use? What is kind of under the hood?
Yeah, we provide a voice recognition algorithm for voice trigger and local command recognition. And the algorithm basically is adapt TTNF modeling for acoustic model. And it's a hidden markup model with library search for the voice recognition. Yeah.
And in terms of hardware, what kind of hardware do you need to run this algorithm on? It can be like a DSP, CPU, or you need some special acceleration for these algorithms. What is the best kind of optimal hardware for your algorithm?
Our target is to apply our algorithm on as a lot of platform as possible. So it's implemented in C code, so can easily deploy it to a lot of platform like a DSP, MCU, NPU, CPU, and so on. Yeah.
And what will be the most optimal? I mean, what is for people if they want to develop and run it? What will become the optimal hardware for this?
Yeah, there are a lot of production calculation in the NN calculation. So like a SIMD, the SIM instruction will help a lot to improve the performance.
Interesting. And the final question, what is your business model, and do you already have customers, and kind of in what areas for you?
Yeah, we license to like a IC vendor or design house or some brand product brand customers, and our business model is including the intro license fee and the royalty fee. Basically, it's royalty based.
Okay, so your licensing, basically, that's kind of your core business with licensing.
Yes.
Okay, great. Thank you. And you provided your contact information if people would like to try and interested. Yeah.
Thank you.
And actually, one more question. Have you benchmarked your algorithm compared to like what other people use in terms of kind of keyword spotting? I mean, what is performance-wise? How do you compare your algorithm compared to what other companies use in this space?
Because we just do the voice recognition part, so we cooperate with some partner with the pre-processing, and we have some benchmark with some existing product in the market. Our performance of workable is comparable or more better than some existing product in the market.
Okay.
We want to thank especially our strategic partners who have made it possible. We have our executive sponsors, ARM, the Software and Hardware Foundation for tinyML, then at Impulse, tinyML for all developers, Qualcomm AI Research, advancing AI research to make efficient AI ubiquitous, Sentient end-to-end deep learning solutions for tinyML and Edge AI, then platinum sponsors, Reality AI, add advanced sensing to your product with Edge AI, tinyML, and then Renaissance, broad and scalable edge computing portfolio. Our gold sponsors, Latent AI, adaptive AI for the intelligent edge, Maxim Integrated, enabling edge intelligence, Seed Studio, the IoT hardware enabler, SensiML, build smart IoT sensor devices from data, SynSense, builds sensing and inference hardware for ultra-low power embedded mobile and edge devices, and our silver sponsors, Aeon Devices, Deep Light, EMSA Visual Sense, Greenwaves Technologies, Gravity Inc., HODG, Imagimob, Kixo, Rixen Technology, and SAP. So thank you everyone for staying with us today, and see you tomorrow.